Okay, so to find the y solution for this, we need to find the determinant d sub y. It starts off 1, 2, 2, just like the original D matrix did. But the y column, the second column, instead of -5, -1, -3, we use this 1, 0, 0. And we like to see those zeros. That'll make it easy to compute. The third column is the z column, -2, +2, and -1. So copying the first two columns to the right here, 1, 2, 2, 1, 0, 0, we can start calculating these diagonal products. So the first one is 1 times 0 times -1, which is 0. Now we're adding the next one, which is 1 times 2 times 2, which is 4. The last one is -2 times 2 times 0, which makes the whole thing 0. And then we subtract what we get going the other way, the other diagonals. That's 2 times 0 times -2 is 0, which is always nice. The next diagonal over is 0 times 2 times 1, which is another 0. And finally we have the third little diagonal, -1 times 2 times 1. That adds up to -2. So our d sub y here ends up being 4 minus, and -2 is 4 plus 2, which is 6. So d sub y equaling 6 means we now know what the y coordinate of the intersection of these three planes. Remember, a 3 by 3 system is actually three planes, and they intersect, generally they intersect at a point. So now we know the y coordinate of that point. Y is equal to d sub y divided by d. And that's equal to 6 divided by -15. Now a positive divided by a negative is a negative, and 3 goes into 6 twice, and 3 goes into 15 5 times. So our y coordinate of the intersection of these three planes is -2/5. So we can add the y coordinate to our solution point here. We have the x we already found. The y is -2/5. And there's just one more to go to find the z. So here we go. One more determinant, and we'll have it. We'll find d sub z next. And d sub z is the original matrix that we started with, but covering the z column with 1, 0, 0. So d sub z, let's put this down a little bit lower here. D sub z. So the first column is 1, 2, 2, like it was in the original D. Second column was -5, -1, -3, as it was before. And now the z column is 1, 0, 0. We cover the z column with 1, 0, 0 this time. To calculate this determinant, we copy the first two columns, and then we can start our process of multiplying down diagonals. So the first is 1 times -1 times 0. That's just a 0. And the next diagonal over, we have another 0. So that makes that 0. -5 times 0 times 2 is 0. And finally we have the third diagonal over, 1 times 2 times -3. That's -6. And then we subtract the diagonals going the other way. So we have 2 times -1 times 1 is -2. The next diagonal over is -3 times 0 times 1, which makes that whole term 0. And the last term is 0 times 2 times -5. Well, the 0 makes that whole term 0 too. So yeah, that's right. So d sub z is equal to -6, negative a -2 is +2, and so that's -4. So d sub z is equal to -4. Therefore z is d sub z divided by d is -4 divided by -15 is 4/15. So we now have our final coordinate. The z-coordinate is 4/15. So the solution to this linear system, the intersection point of these three planes has these x, y, and z coordinates. So this is the solution to our linear system.